So today we're going to be talking about something that is very important if you want to get any real good life out of the various parts that connect to your hot end. And that, my friends, is strain relief. Now you may notice that on this hot end assembly that I've got, I have these wires zip tied to this post. And if we move over to my copycat machine, you can see it just a little better. And that is what we call a strain relief. Now, why is it important to have a strain relief? Well, let's talk about that. When a wire moves back and forth, as it does on a printer, in this case the x-axis, going left and right, that strains the wire. And this is basically what's happening. Get a good view here. So that wire, okay, that wasn't a good example. This filament's a little brittle. That wire is getting bent this way, and then back this way, and back and forth. And eventually, if it keeps doing that on a sharp enough angle, well, that creates a stress point where the filament, or, well, wire that we're talking about, is just going to break. And when you have a broken connection, now your heater doesn't work, or your thermistor doesn't work, or your hot end fan doesn't work, or your parts cooling fan doesn't work, and that's no good. So, how do we fix that? Well, instead of letting wires get dragged all over the place in an uncontrolled manner, we use something called a strain relief. Any good hot end assembly is going to have some form of this to try and prevent the wires from breaking, especially things like thermistor wires. So let's talk about that. This thermistor, it's a bolt type thermistor that goes into the heat block right behind the heater cartridge, right? Now, when I first got my bolt type thermistor, it lasted maybe about 2 weeks before the wire got bent back and forth, and it got strained. It then popped right off, and it no longer worked. Now, that was before I implemented strain relief in my companion mount system that I designed. But after I implemented strain relief, I'm using this new thermistor, the replacement thermistor, and it's been going strong for well over 6 months and well over 1,000 hours at this point. So the concept is definitely solid. It definitely is a thing you really need to do. And the same kind of thing goes for not just at the hot end, but in the back as well. You see, these wires, the ones that go to ultimately things like the stepper motor that drives your extruder, or the sensors like the ZN step sensors, or power to the X-axis motor, things like that, those are moving back and forth all the time as well. And this uses what's known as a drag chain. So essentially it creates a nice smooth movement over a long arch instead of just like a pinched up binding movement that would normally happen if you weren't using these. And you can get these on Thingiverse. They're fantastic. Literally everyone with an Ender 3 ends up printing them like as one of their first things, and that is strain relief. That's really important. The more wires move, the more strain there is on the point that is being twisted and bent and kinked as it goes around. So the more you can create a wide arching effect, the better, because then you're not letting the wires just kink up and essentially break. So that's just what I wanted to talk about. Strain relief is important. And it even goes into like your warranty. For instance, my Easy ABL from TH3D, if you do not implement a proper type of strain relief, you in fact will void your warranty, because it's a well-known issue that, you know, when a wire moves this way, it's going to break. So, things to consider. It'll save you money in the long run. It's easy enough to implement, and it also makes things look a bit more tidy.